We have a substantial understanding of how the universe unfolded from a unique singularity 13.8 billion years ago, and how the first stars, galaxies, and black holes formed. But what, in fact, happened before the Big Bang? Stephen Hawking responded to this question with a definitive nothing, as time, too, only began with the introduction of the universe. However, some experts have a slightly different belief in this regard. In truth, the Big Bang was by no means the beginning of everything, but simply one of countless Big Bangs that are still happening to this day. This also means that our universe does not encapsulate the entire picture, but is merely a small link in an endless chain of universes. But is there any real evidence that makes this assumption more than just an amazing theory? Surprisingly, there is. The James Webb Telescope recently recorded a discovery that suggests the nearly impossible conclusion that our reality is currently merging with other universes. When astronomers in the 1920s began to study distant galaxies, they encountered something very startling. They realized that most galaxies were moving away from us. In fact, this new finding even fueled speculation that Earth could be at the center of the universe. However, experts soon became wiser. Further observations showed that, on balance, not all structures are involved in this cosmic mass exodus. In fact, our Milky Way and the Andromeda Galaxy are actually moving toward each other and are expected to merge in just over 3 billion years, according to our current state of knowledge. Around a century ago, however, the journey of the galaxies initially seemed an unsolvable mystery. But after decades of detailed analysis, experts finally discovered the real reasons behind the strange galaxy movements. We now know that, strictly speaking, it's not the galaxies that are moving through space. Rather, space itself is constantly expanding. However, the expansion of the universe isn't exactly as simple as it might initially appear, since it has no central origin point. This implies that everywhere in the universe, it appears as if other objects are moving away from you, regardless of the observer's location. This observation would always make it seem as if you were at the center of the universe, from which all other structures were escaping. This observation also provided another, not insignificant, piece of information. The universe itself doesn't have a fixed center. In simple terms, everything is moving away from everything else due to cosmic expansion. But that's not all. Scientists have found that space is not only expanding, but that the rate of expansion is actually increasing. The farther away a galaxy is from us, the faster it is receding. Recent studies show that 97% of galaxies in the observable universe are receding from us faster than the speed of light. But how is this even possible? Doesn't this contradict Einstein's theory, which states that nothing can be faster than light? Well, not exactly. Einstein's theory only applies within space itself. As the galaxies in reality are stationary in space, and their movement is based on the expansion of space itself, no cosmic speed limit is broken. Interestingly, it was Einstein himself who recognized that such faster-than-light speed is possible within the confines of space. Regarding the Big Bang, cosmologists generally assumed that cosmic expansion began with this event. It's unsurprising since space, matter, and time were formed together from a unique singularity. But how could something that didn't yet exist have expanded beforehand? Often, the Big Bang is imagined as a violent event in which the universe literally exploded into existence. According to this view, the beginning of everything that ever existed, exists today, and will exist in the future lay dormant 13.8 billion years ago in an incredibly hot, dense point. One might imagine the corresponding singularity as a tiny spot in true emptiness. But how does this fit in with the assumption that the universe is boundless? Some experts argue that the universe must have always been infinite, even if it is infinite today. In other words, the Big Bang didn't happen at a specific point, but everywhere. This also means that the first galaxies didn't form in a particular region of space, but everywhere in the universe simultaneously. Similarly, matter also appeared everywhere in the universe at one point in time. Despite this, the typical image of the Big Bang still leaves some crucial questions unanswered. After all, what caused something to suddenly appear out of nothing 13.8 billion years ago? How could something come from nothing? And was there a trigger, or was it pure coincidence? We simply don't know the definitive answers to these profound questions, and they have always been highly controversial among experts. The bottom line is that the Big Bang Theory alone cannot explain all the observable characteristics of the universe. These include, for example, the isotropy of the universe or the way it consistently presents itself to an observer in the same way, regardless of the observer's viewing direction. This is where cosmic inflation finally comes into play. This phase of incredibly rapid expansion of the universe is thought to have immediately followed the Big Bang, transforming the universe from something minuscule into something significantly larger in less than a trillionth of a second. But what drove this essential process? Some experts point to a mysterious force that is believed to still drive the accelerated expansion of the universe, though its origins remain largely unexplained: dark energy. The James Webb Telescope's mysterious discovery fuels an incredible theory. However, it should be noted that although dark energy and the associated fields are a potential cause of cosmic inflation, we don't know whether there truly is a connection between the dark energy of that time and the dark energy of today. However, dark energy is currently seen in space research as the driving force behind the accelerated expansion of the universe. Although this mysterious form of energy has had a firm place in astronomy for over 25 years, its actual existence has yet to be proven experimentally. Some researchers suggest that it might not be dark energy driving cosmic expansion, but something we typically only know from science fiction, believe it or not. A study published on December 12, 2023, in the Journal of Cosmology and Astroparticle Physics concluded that what our instruments detect as the expansion of the universe might actually be the result of universe mergers. To understand the basis for this unusual theory, we first need to delve into the Hubble constant. Essentially, it shows how fast the universe is currently expanding. But it also embodies a huge mystery. When determined based on cosmic background radiation, the Hubble constant is 67 kilometers per second per megaparsec. However, when based on supernovae, red giants, gravitational lenses, and variable stars, the Hubble constant suddenly becomes 73 kilometers per second per megaparsec. In other words, the universe is expanding faster than it should be. One possible explanation is that the previous measurement results were blurred by errors. To determine whether this is indeed the case, the James Webb Telescope recently examined 320 variable stars and delivered the sobering finding that the previously observed deviations align with reality. Thus, the Hubble constant discrepancy is real. But how can it be explained? Adam Rees, Nobel laureate in physics and lead author of the study, suggests that we may have misunderstood the universe. There could be forces and processes that we simply haven't accounted for in the standard cosmological model. These could include dark matter or dark energy, for instance, but it might be something even more substantial. Has our universe been merging with another? Jan Amjorn from the University of Copenhagen believes it's more prudent to abandon dark energy concerning the Hubble constant discrepancy and instead consider the possibility that our universe is currently merging with other universes, and not just recently. The real reason for cosmological expansion is suggested to be that our young universe was once absorbed by a larger parent universe, and since then, our universe has been doing the same to other child universes. But how do you even come up with such an idea? By developing a mathematical model that examines the effects several interacting universes could have on our universe. The experts' calculations showed that the merging of universes would increase the volume of our universe, an increase that our measuring instruments interpret as an expansion of the universe. At the same time, they determined the rate of expansion of the universe that would be expected in such a scenario. The results surprisingly agreed with observations of space even better than the traditional cosmological model. However, even the most impressive theory needs to be confirmed by real observational data. But how do you observe a different universe in the first place? Not by any stretch. To test the theory of universe mergers, researchers are currently conducting various studies to investigate the cosmic microwave background. This radiation, a remnant from the time shortly after the Big Bang, could contain unfamiliar attributes that may one day bridge the gap to other universes.